I pulled a few different varieties of multimeters out that we happen to have in the lab here. So this is that same model that was shown in the slides. You can see I've got, my DC voltage, amps, resistance are the important ones. This is the diode checker. You can see that this one has a separate on and off switch, and then a knob to select, whatever I'm trying to measure. These two here, so this is a slightly nicer than this one, but still a relatively inexpensive digital multimeter. This one is auto ranging, so you can see there, and you can't really read the green here, but there's a V with a squiggle, which means that's AC voltage. There's my DC voltage. This is ohm. So this is resistance, diode, and right here, that's a little circle with a bunch of waves coming out of it. That's the beeper. So you'll use that for continuity checking. So that is just something where if you have a direct electrical connection between the leads, it'll make a buzzing or beeping sound. I have a capacitance measurements here, and I have, again, you can't really see it because the green doesn't show up too well. This says HZ, which stands for Hertz, which will tell me the frequency of any AC signal that it's measuring. And then I have a number of different current ratings. And you can see here on this one, I have my milliamp there. I have my common, and I have a 10 amp. So most often I will be plugged into here, but if I'm going to go to this large current setting, I'll probably have to move it over here. In particular, when you have these auto ranging ones with this relatively simple knob, you'll often have some buttons up here. So in particular, if I go to this resistance and other stuff setting, so you can see it says kilo ohms currently. So one thing I can do is I can manually adjust the range if for some reason it's selecting a range I don't like. The other thing is I can switch between the different modes on this particular setting, right? Because this is the one that has a whole bunch of different settings. So now you see I've got this little speaker symbol up there, and if I touch the two leads together, you can hear that beeping. Yeah, and then there's a few other more advanced functions there, which off the top of my head, I would need to pull out the manual for this multimeter to figure out exactly what those do. Also, one thing to note with this is if you're on any one of these, it's just going to stay on. In fact, almost all of your digital multimeters are going to have a timeout. After a certain amount of time, it'll either beep to remind you it's still on so you don't kill the battery, or automatically turn itself off. And then this is a similar multimeter, but this is actually a more expensive, nicer model. This is a Fluke. You'll often hear multimeters referred to as Flukes because it's a very common brand. For this first activity, this is just to get everyone familiar with proper usage of the multimeter. You're going to need, I hope you guys should have a bulb holder with a bulb that has these little screw terminals. You're going to need some wire to make some leads out of. You want a wire cutter and wire stripper so you can cut and strip that wire. So I've already done some of this So what you want to do is basically cut off a length of the wire and then strip the ends. And then you want to feed that wire underneath these screw terminals, which you can loosen. Right. So you can see that I just took a length of wire, I cut it, I stripped the end off, I wrapped it around like this, and now I can tighten down on the screw. And all that is to give me a nice electrical connection. And then we're also going to need some sort of power source for this. So if you have an adjustable power source, you can get a little bit more out of this. But if not, you should be able to, in your surface mount kits, you'll have the battery holder like this, and you should have a 9-volt battery that you can plug into that. So what we want to do is hook up positive lead of the power supply and negative lead of the power supply, whether that's your battery or an actual power supply, to this bulb. And then when I apply power, I should be able to see the bulb light up. So like I said, I have an adjustable power supply, so I'm going to hook that up and apply roughly 9 volts, just to give you an idea something that should be similar to the battery. Right, we can see I've got a nice bright light. And in particular, because I have this adjustable power supply, I can vary the voltage and see the dimming and brightening. So higher voltage, brighter light, lower voltage, dimmer light. And if you're wondering why it sort of looks like the bulb dims when I raise at some point when I kept going up, that's just the camera adjusting its brightness. So once you have that set up, the first thing I can do is I can take my multimeter. In this case, I'm using this yellow one on the right side of the screen, and I'm just going to measure the voltage across this. So right now you can see basically I have 5.6 roughly. You know, it's going to vary a certain amount. And then along with that voltage measurement, I want to basically take my multimeter and I want to measure the same current with it. So in this case, here is the power coming out, the positive lead of my power supply. So this would either be the positive lead of your battery terminal or from your adjustable power supply. I want to connect either with some alligator clips or whatever you have available in your lab onto the positive lead of a multimeter, right? And I'm going in here into the positive lead, and then I want the negative lead of the multimeter. So from here through this lead, and I want to clip on a second alligator clip or lead. I want to clip there, and then take the other end of that and hook it in to my bulb. So now I have a complete path from the power supply into the multimeter, out the multimeter to the bulb, back to the power supply. And now I have this particular multimeter reading on current. You can do this just because I have 2 multimeters. I'm using two multimeters so I could measure current and resistance at the same time. If you don't have two multimeters, you can basically use the single multimeter and swap back and forth. So, and all you basically would want to do is practice taking voltage and current readings. In particular, paying attention to that when I'm measuring voltage, I want it in parallel. And I want to make sure that when I put it in series, that I don't try and measure current in parallel. If you have an adjustable power supply, you can actually, and let me try and get this all on screen at the same time. So remember, this is current, and this is voltage. Get my hand out of the way, right? So now, as I do this, you guys should see that both are changing at the same time. And in fact, you can also see that even when the bulb really doesn't look like it's on, I'm still actually getting some current flow through it. So if you have an adjustable power supply, you can actually take multiple measurements at different voltages and currents, and you should be able to calculate, well, you can then plot those, and what you would expect to see is a straight line and be able to, the slope of the line being the resistance. But in fact, it won't be a straight line. And this is sort of the first wrinkle of, oh, wait, not everything works in the lab as in real life as you would expect just by naively applying the theory. And the reason it won't be a straight line is the filament in this bulb is where most of your resistance is. And the way that it makes light is by heating up. So it is actually getting very, very hot. And because of that, as it heats up, the resistance doesn't change. So you can see right now, I have 6.63 volts and 150 milliamps. So a bit more than 4 ohms is what I would expect the resistance to be. So if I now just take the bulb out of the circuit and measure the resistance with the multimeter, so I'm disconnecting it with everything, and I just measure the resistance by itself. Sorry, it's a bit tricky. It's actually 5, right? So it doesn't quite match because the resistance has actually changed because the filament, as the filament heats and cools. So, I mean, basically, you guys should just practice using the multimeter. This first activity is just to get you hands-on, hey, because some of you may not have used a multimeter in the past.